Good afternoon, all. Venu Madhav graduation from IIIC Vijayawada in Electronic and Communication Engineering in 1999. His professional experience of 23 years spent into multiple products development domains in the area of hybrid microcircuit and automated electronic and semiconductors, and have served multiple customers ranking from the Indian defense. His professional journey cuts into product designing and development, testing, project and programming management, and business development. He has led many innovative product development with very big, diverse and multi-discipline teams, and was the instrument of launching first of their kits of products. He is currently working as the NHP Semiconductors, Netherlands, as a senior principal programming manager, and is a part of Circle of Network Transmission Leadership Team. Thank you, sir. Welcome.
Hello, good afternoon to all of you. I think I feel like I'm a student here because it's been quite a while that I stepped into a engineering college, and I was told that you are all first years, right? So you joined this college with a lot of ambitions, trying to become something, someone at the end of the fourth year, right? They keep that excitement, right? So I was also like you many years back, and let's see, I will take you through a journey today. I believe with this journey, at least if some of you are inspired, and if you take something from here and put that into your academics, I'm for sure I can tell you that you will excel. Okay? How many of you have heard about semiconductors? Just wanted to know. Okay. So, what does the semiconductor do? Anyone? Go on. Okay. No, that's fine. I think we are in unprecedented times. Yeah? The world is changing, the landscape is changing. Today in the talk, I'm going to focus on semiconductors because I think the core fields like electrical, electronics, instrumentation, communications, all of us who have opted for this core engineering disciplines, I think it's also kind of unfortunate thing that many of us at the end of the fourth year shift gears and become Java programmers, SQL programmers, do whatnot. What we don't study in engineering, but we do all that. But there is also a purpose, right? Why are you here? Why did you select electronics, electrical, computer science, IT? How many of you are from electronics? Wow, that's quite a decent number. Electrical? Okay, not bad. Okay, cool. Okay, so let me take you. So the semiconductor industry is having an unprecedented growth. So we are in 2020s. In a decade to come, the semiconductor industry would soon become a $1 trillion industry. So you will find everywhere connected devices. So as you see, there are many verticals: automotive, industrial, wired communication, consumer electronics. All of these segments will see an unprecedented growth. So when I say unprecedented growth, This means that I'm talking about the chips, the intelligent chips that gets into every device, every smartwatch that you wear today, right from the Apple Watch. You might have heard this. So if you feel sort of getting bored, probably wait for more slides to come. This is just a beginning. Okay. So I think these chips are kind of bugs in the bed. The size of these chips, tend to go from less than 1 millimeter square area all the way to 10, 15, 20, 25 millimeters square. So how many transistors do you think we can pack in a size of less than 1 millimeter square? Any guess? So size of less than 1 millimeter square is kind of a small bug in the bed. That's the size I'm talking about. So you can literally pack a billion transistors. So that's the cutting edge I'm talking about. Okay. And if you want to really witness the growth and be part of that growth, you need to really hook on to these subjects and get in depth. And don't stop at graduation, continue doing masters. Okay. So again, this is not a monologue. Yeah? I'm not here to only talk and deliver a lecture. I want this to be interactive. So not many quiz questions on the screen, but I'll be asking you as I continue this. So how many chips? When I say chips, these are not Lays. Yeah? These are not potato chips or banana chips. These are really integrated circuits. So in the industry parlance, we call them as chips. So how many chips do you think are packed in a typical car that you see? Any guess? Go ahead, take a guess. Millions. That's too much.
1,000?
Hundreds.
500.
Hundreds. 100 plus. Okay. Anybody else?
1,000.
1,000. Decent number. Good. Who said 1,000 plus? 1,000? Good guess. So, a car as of today is a computer on wheels, and it has an average of about 1,400 chips. So, I think you will not be able to visualize because you don't rip open a car, isn't it? You don't get to see what is in. But there are about, on an average of 1,400 chips packed inside a car. This is really unprecedented because if you go to, the generation, 80s, 90s, even 2000s in the beginning, in India, if I can talk about, you would see mostly Fiat's ambassadors and Hyundai taking off, let's say from 2000. So with the advent of internal combustion engines and common rail diesel systems and electronics becoming quite significant in cars, you have many functions in a car. It's just not the driving. Yeah? You sit in a driver's seat and you kind of put full gas, the throttle, yeah, we call it. But that's just driving, yeah, because the car has more features. And where do you think these are coming from? There's an infotainment, yeah. You have a multimedia kit at your disposal. There's a chassis system, it's powertrain. There are about 135 electronic control units in a car. Can you believe? And these 135 electronic units communicate with each other. Yeah, there's a lot of arbitration going on. There is some units are talking, some are listening, and your functions are served. So when you sit in a car, did you ever imagine what happens when you press your accelerator? What happens? How does a car know that you want to go? You're switching the gear, you're pressing the accelerator pedal, which you call the throttle. What happens? Any guess? So it translates into a driver demand. So the fuel quantity is adjusted. So if you are pressing the pedal, the amount of the distance that the pedal travels is translated into fuel quantity demand. And that much of fuel is dispensed and burnt. And that is why you get acceleration. Okay, so today's cars, I'm not talking about completely electrified systems. There is no question of internal combustion engines. I'm talking about a typical car that you see on the road. Does have an internal combustion engine. And it has hydraulics, it has electronics, and it's a collaborative system where hydraulics talk to electronics and they listen to you, yeah, and they just serve you. Okay? So there's a lot about cars, and automotive electronics is a field that has quite a bit developed since last 25 years. And I think all of you want to drive a Porsche, yeah, drive a Merc, a BMW. Probably if you do that in Hyderabad, you know what happens, right? So maybe you dream of driving these cars on a German autobahn where there is absolutely no speed limit, right? So to do that, I think driving is thrill, it's interesting, but also getting to know what is really happening inside the car is equally interesting, and you will get thrilled. So this visual shows you, typically what sensors are inside a typical car, right? So I will not go to each of these, but let me tell you that there is engine management system which needs to know what is the temperature outside, the ambient temperature outside the car. It has to know what is the fuel temperature. Yeah, we need to also account what is the pressure outside. And then there are a lot of sensors. For example, airbags. Yeah, you saw what happens when a BMW rushing at a speed of 200 km per hour goes and hits a metro pillar. You saw that, right? A lot of accidents. So what happens then? There's an airbag which gets deployed. But if you don't wear a seat belt, that doesn't get deployed. So if you wear a seat belt, there's also a sensor which senses that you have on a seat belt. It calculates the speed. It sees what is the impact of the collision, and then it inflates the airbag onto you. Right? So if you are driving a car, remember that there is awareness. There's a lot of sensors working for you to make your travel smoother. So what's happening worldwide? Let's say I have a picture here from 2001, where everybody were latching onto laptops, desktops, mobiles, gaming consoles, home audio, and hi-fi systems. From there, we have moved to smartphones. I think literally we are now 1.3 billion in India, 1.4, 1.3. How many mobile phones do you think India has?
300.
Yeah?
300.
300?
Something 300
billion. Goodness. So you can imagine the extent of mobile phones proliferating into your daily life, right? You take it literally everywhere. You can forget yourself, but not your mobile phone, right? Yeah. So it distracts you, but you don't see that as a distraction. You see that as a lifesaver, right? If the battery is down, you're dead, right? But that's all happening for a cost. So from here, we are moving to the secure edge. So completely into smart world. So what does smart world indicate? It means that literally everything is connected. So you are connected even to the traffic pole. So when you're in the traffic system, yeah, you don't talk to the traffic pole, right? But very soon, if you're in a car, there is something called vehicle to infrastructure communication. The vehicle talks to the traffic, and they both handshake, and you are informed, how long you need to wait. or if it is getting really longer wait, what is the reason, right? Many of you have experienced when you are in a car, you don't have to necessarily drive. But if you are in a car, just sitting on the passenger cabin, the car is moving, there is a big truck in front of you, a 2-ton, 3-ton truck. And you have seen, right, how trucks are driven in India, right? A huge truck, container truck in front of you. You want to overtake. Yeah, it's kind of a 60-feet road, or less than that, 40-feet road. You want to overtake, but you cannot. You're afraid. But your brain says, come on, overtake. So you have that adrenaline rush in your body to overtake the truck. But most of the times it's fatal. Yeah, you hit the traffic that is coming in front of you. So there is something called see-through systems. It's called STS, which OEMs like General Motors develop. So what happens is every vehicle communicates, and what is in front of the truck is actually displayed on your visor, on the cockpit. So that means it's a clean through system. You can see through the truck what is in front of the truck. So that's the turning point, right? So when I say vehicle to infrastructure, it's called V2X. So it could be X, could be vehicle to vehicle, vehicle to infrastructure, and vehicle to also a human. So that's the security I'm talking about. So very soon you will see that there are AI. What is AI, by the way? What is that? What is AI? Maybe one of you can say it loud. Sorry? Yeah, go ahead. Training machines. Not bad.
Making our work easy using
Yeah.
making our work easy using software or depending on
I didn't get your initial sentence. What was that?
making work easy by using software or lesser work
Good.
by using hardware programs.
I take that. Anybody else? Okay. I think most of it can be encapsulated, in the statements that you made.
Adding that
So-
thinking capacity to a machine.
Sorry?
Adding that thinking capacity to a machine.
Yeah. I think we can't emulate, I think we are also cloning ourselves now. So we become a digital clone of ourselves. You will also see that in the future. Not that far off, next 10 to 15 years. But yes, to make the machine intelligent, that it works for you. So you will have AI-enabled chips literally everywhere. 5G is going to take the entire world by a storm. Place where I live in Europe, I think 5G is already there, and we are using it quite a bit. So in India, probably in 1.5 years, you'll also see 5G taking over. And everybody talks about 5G, right? What is 5G? Why is it, is 4G not good enough? Why do you need a 5G? Okay, go further, more advanced. So faster means, how do I take it? Right, how do I take an advantage of speed? So the streaming, so you can improve the gaming speed, is it?
Large distance coverage.
Okay. Anyone else? So that gentleman here said it increases the speed drastically, which is correct. What about the bandwidth? Yeah. So bandwidth is like 40 feet, 60 feet, 100 feet road, yeah? And the speed is at which you're running on the road. I hope it's clear. And I mean, what is bandwidth and what is speed? So, can you imagine what 5G can do? Because I will come to that, which is very interesting. autonomous driving, right? So cars driven, self-driving cars.
Tesla.
Yeah, there are also many which you don't know. There are many, of course, Tesla, thanks to Elon Musk. So the self-driving cars, they actually breathe 5G. So there are a lot of real-time decisions that need to be taken quite fast. So when you completely hand over to the car, saying that you drive me completely, I don't intervene. That's the nirvana of driving. That's the complete self-driving. So when you do that, just imagine you're on a roundabout. In Hyderabad, it becomes Chaurasta. Okay, a roundabout. So there is a school bus carrying 50 odd kids, let's say aged between 5 and 8. And from the other side, there is an young couple just driving in their car. And you are there, from one side. And from the fourth side, probably some old couple are coming in. And all of them are self-driving, mobility vehicles. So, going at different speeds, basically. And the system realizes, and there's a flash coming on your cockpit and everyone else's cockpit that, there is an unavoidable collision. Collision is going to happen, right? Now what happens? If you're a human being, what would you do? What is your instinct? You try yourself, right? You try to save yourself. Okay, so there is a field called ethics in artificial intelligence. AI ethics. That's again, a field that is budding. You probably would have experienced this by seeing this in a movie called Robo, right? Ethics in artificial intelligence. So which means that human instinct always says, first you protect yourself, but it's not looking at any other parameters or variables. So what happens in this case study is, when a collision is unavoidable, then it also looks at the social status, yeah? So when I say status, it looks at the age, it looks at many other factors. So what happens is, the systems communicate amongst them and then they say that, they decide that, okay, an uncoupled car, I will take the hit because I want to protect that school bus, right? So you can't take the decision if you are a human. So self-driving cars also have that as an additional thing. It's more about ethics. How do you teach machines ethics? So it's not just a thought process of one. It's looking at variety of variables around you and then taking a decision, right? So at the end of the day, the collision could also be quite manageable thing. It is just swirling and then hitting a barricade. That's it. No life is lost. But even the thought of who's going to take the hit is itself, quite triggering and instigating. So that's the level of sophistication we will get into. So 5G really plays the role. So I was telling all this because of the speed, the decision making, the real-time decision making. Okay, that's where the speed is used. And this symbol shows that your car can really see, visualize 360 degrees around it. So today, can you say how does a car see? How does a car see? When I say how does a car visualize its surroundings? Sensors, someone said? What kind of sensors? Sorry? Camera? Camera you saw, right? Front camera, rear camera
Infrared.
in a car.
Infrared sensor.
Infrared. Good one, but that's more for the night vision. LiDAR, somebody said LiDAR. Good one. What is a LiDAR? Yeah, proximity sensor. What is a LiDAR? Yeah, it sends pulses of laser. Yeah, and it calculates the distance to the target. Okay, radar. Did you also hear what's a radar?
Yes. It's in sound waves.
Radio waves, yes. So there is in the ascending order, I would say you start with cameras, infrared cameras, get into the next level of sophistication and resolution, that is radar, and the third one is LiDAR. But LiDAR is prohibitively expensive, so it needs to be affordable. But that's where you can see the resolution to 2 centimeters, and it actually constructs a 3D view in front of you, because it takes thousands of pictures or thousands of samples, measurements, and builds a picture which is quite real. Which also means that there's a heavy computing. It doesn't come for free, right? Because the video camera, you would have seen, you would finish your memory quite fast. So you also need to store this somewhere and only use it and flush that out immediately. For all this, you need speed. So this is what is going to happen. There will be 75 billion plus connected devices by 2030. 50% of the cars, mobility segment, will be electrified, completely electrified. There are a lot of regulations in the countries. By 2024, 2028, you can't run an internal combustion engine anymore. 50% would be L2. So this is the level of automated driving. 5G will cover 60% of the world. AI semiconductor revenue will be about 75 billion by 2025, and 20% of this will be smartphone volumes. I'm not dwelling on this, but this is quite important thing, functional safety. I think safety and security are also of paramount importance in the mobility sector. Many people confuse safety to security, but they are totally two different things, right? So functional safety, there is a standard ISO 26262, which actually says, in the context of an internal combustion engine, the functional safety refers to a condition where there should not be any unintended acceleration. That means you're reversing your car from your parking spot. By no means, in any situation, it causes acceleration, even with a software bug. So there's a lot before a car is released into the market. The functional safety assessment itself is a big ocean, big world. So all that I have said are actually standing on these pillars, on this foundation. Everything safe and secure. We have sense, that means everything is aware, everything is conscious, machines are getting conscious. Think, everything is smart and learn. Connect, everything is connected. And act, everything efficient. So when I say efficiency, it is electrification. So how are semiconductors going to revolutionize the vehicle innovation? You see, automation I talked about level 0 to level 5. So mostly we are here, manual driving, then with a limited driver's assistance, you are in level 0 to 2, and then this is really level 5. Then the second is electrification, from combustion engine all the way to pure electric vehicle. And the third one is connectivity, from no connectivity all the way to a fully connected car which is 5G enabled, which has everything. What NXP Semiconductors, where I come from, is doing is, we have a zero vision. I hope it's a mock signal, or is it real? We need to vacate this place. No, it happens in my office. That's fine.
One period is over.
Okay. That's fine. That's good news. So at NXP, we look at autonomy, which means we make products with an objective of not having any accident. Electrification, we constantly try to make the systems emission compliant. Zero emissions is almost like, there's no carbon footprint. The third one is connectivity, zero time wasted, intelligent transport systems, and new opportunities for infotainment. I would not dwell much on this because I think I already told in the autonomy from no automation all the way to level 5. Electrification. So I think in India, there are a lot of car companies including Suzuki, Tata. Probably Tata I'm not aware, but Suzuki has definitely introduced plug-in hybrids. So I think you are witnessing a big change in India on electrification. There is something called a program called FAME, introduced by Ministry of Industries. This is faster adoption of electric vehicles in India. So there are a lot of subsidies given also to develop the infrastructure in India. And in all this, there are semiconductor chips getting in to make the systems very efficient. So BMS, battery management systems, you have inverters, all that, in the vehicle. So the more you are going towards electrification, the more electronics you are packing in your cars. Yeah, on the connectivity. So what do you see? What do you want in your infotainment system? What do you want in a vehicle? You want to buy, let's say, I think he's already sleeping, but hey buddy, you got a Porsche, yeah? You are in driver's seat. So what do you expect your infotainment system to be? What do you want? Sorry? No? What do you expect of an infotainment system in the car? Comfort. Comfort is a different one. I'm talking about entertainment. What kind of a multimedia? How do you want to communicate with your car?
If the driver sleep also, the car will go. If the driver is sleeping also, the car will go. Automatic.
Okay, I'm talking more on the infotainment system. So you heard Apple CarPlay? You heard about CarPlay? If you have an iPhone with CarPlay, you actually, the moment you step in the car, your cockpit of the car is your mobile. So all that you have on your iPhone or Android is coming directly there. So you don't have to do anything. So either you can Siri for iPhone users or Google Assistant or Alexa. You can actually talk to the car just like you talk to your mobile or with your home automation system. So you can, with very ease while you're driving, you can just ask the car to navigate to a different place. So there is already a navigation, right? So you can send the address before you step inside the car. But if you have changed your mind, you can just say, take me to a different place. It's already, the car is working for you. You can say, play this song from Spotify. Yeah? It would, or Amazon Music, whatever you want. If Ghana is famous here, let's say that. So you can also stream videos. Yeah? These are all connected services in a car. And which means that voice recognition itself, so voice recognition, speech recognition into a readable code, understandable code by the machine, and translating this all the way to the cloud and getting that information back and relaying it to you is a big deal. It doesn't come just like that. So it indeed calls for a real pack of electronics, application software, which will make this dream come true. But it's no more a dream. In high-end cars, it's already there. You can also retrofit, by the way. It's not that you have to buy a Merc BMW or a Porsche. You can also do that in a Suzuki or a Tata. So all that I said translates into one car with different visions and with varying technology evolutions. The self-driving car will be very conscious. It decides, it learns. There's mega sensing and processing, with new infrastructures. The electric vehicle, the transport at top efficiency, absolutely no drop in efficiency. You also need, I think, at least my colleagues and my friends who bought an electric vehicle, Renault or something else, even Tesla, to that extent, they say that if I'm going on a long distance trip, I'm worried because there are no charging stations, and I've seen people, their cars getting stranded on the highway or maybe somewhere during their trip. So I think all the suppliers, including the OEMs, are working on technologies to beat this, to have a very big range that's getting extended. It's not only that, I think affordability is also very important because not everyone can book a Tesla tomorrow, right? Model X, Model M. I think the affordability also plays a big role. And in a country like India, I think infrastructure should be there. So you have a lot of gas stations, but you don't have infrastructure for charging your cars. That should come either through charging itself or batteries. In all this, I think all this needs sophistication. And then the service-oriented car. So my definition of futuristic car, or the car that is many cars that are on the roads, is a smartphone on wheels. So when I'm talking about service-oriented car, you can literally configure your car just like you take your phone and then you configure your apps. It's possible. I don't know how many of you have witnessed, but it's possible as on today. So you can do everything. You can reconfigure. You can say what kind of an ambient lighting you need inside the car. How should your seating get adjusted? So you can record the profile. So the next time you are inside the car completely customizes the environment for you. So as I talk, this is already on the road. Yeah, this is something which I have put just to show you, which I talked about, LiDAR, radar, camera, ultrasound. So how can the car perceive and be conscious and aware of its surroundings? It's all possible with these technologies and companies like NXP. When I say probably you might get a feeling that I'm endorsing NXP here, but any semiconductor company, Texas Instruments, Analog Devices, you name it, they're all working for a common objective to make it more affordable and to have a 360-degree view, which actually helps in taking the level of driving that we are talking about from level 0 to level 5. I just had put a 360-degree view of your radar. What is today and what is the extent that we are planning foray into for tomorrow. Okay, I think I have done a lot of talk. Before I proceed to the next chapter, this would be the last one. Architecture of the car, future car. But do you have any questions as of now? I want to pause for a while and just ask you, do you have any questions? Is this interesting or pretty boring for you? No, you can be very candid. I don't mind. I was like you before, many years, so I can I can relate to your thoughts. Right.
Then the system becomes complex, then what's the
I come to that. Good question. Very good question. I think handling complexity is a new normal. So you have to live with complex systems, but here he's getting exercise to ensure that, albeit the systems get complex, we will find ways to tame that complexity. Okay, let me switch. So this is the vehicle architecture transformation. So today it's a flat architecture. There's nothing. There's a bunch of wires. If you rip open the bonnet, I don't know how many of you have opened the bonnet of your car and really care to see what is inside. Please raise your hands. Good number of people. Good. And what do you see inside? Yeah, everybody sees it.
Twice.
Sorry?
Twice.
Battery, good one. Very good. And? Okay. Okay.
Cylinder.
No, that's right. In a gasoline or a diesel car, you will find cylinders through which the fuel is fired. Who said cylinder? Yeah, it's a good observation. Okay. So it's a bunch of cables, all over, and this is very, very, what do you say? Very messy, I would say. Today's car, you can't make it futuristic. It is unfit. Yeah, you want to say something or can I continue? Okay, thanks. So what is happening now is, as I told at the beginning of the presentation, that there are about 135 electronic control units in a car, which means for engine, there is an engine management control unit. For chassis, there is a chassis control unit. There is an airbag control unit. You name it, you keep on saying. Just add control unit to every function. So many control units. What is happening now is they are getting consolidated. So we call this as domain control system. So the adjacent domains are getting unified into one hardware. So just like the engine management system and the transmission control are packed together, and we call this as powertrain. Right? So there's a lot of consolidation happening, and this is called domain controller. So at least there is a sense, there is a way, there's a plan how to put this here. So the biggest advantage here is you are minimizing the cabling, you are organizing, you are ensuring that, for example, in a flat architecture car, there are sensors and actuators very far off from the processing unit. Most of the times, faults are not recognized, efficiency drops, signal drops, many things. But here, you are making sure that you're organized, you plan accordingly, consolidating domain controls into a single pack. Therefore, these are more efficient, reliable compared to what we have, a very flat architecture. Going forward, we are talking about zonal architectures, zones. So your car, this is also something happening as of today. We call this as software development vehicle. So software is taking over. So you make the hardware. I don't want to, because you're all first years, if I talk about virtualization, hypervisor and all that, probably it's confusing, so I will kind of tell you in a layman's language. You form zones and you have a central computing unit. So you minimize cables. And these are on the edges. So what happens is, even when you receive the information, you don't have to transmit that via cable. There's Ethernet which is taking over. Ethernet is quite speed, it's quite fast. So all the futuristic cards are Ethernet enabled. You can't communicate with communication protocols like CAN. I don't know how many of you know CAN, FlexRay, and LIN. LIN is a serial protocol. CAN is a proprietary automotive protocol. Controller area network. But these are low speeds. So if the inflection point has already crossed, we are talking about 1 gig, 100 megabit per second. So which the conventional communication protocols cannot achieve. You have to really go the Ethernet way. So this architecture, zonal architecture, is Ethernet enabled, and then you have this Ethernet to CAN or CAN to Ethernet, so that the information that is taken out from the cloud is processed inside, via these bridges. But mainly it's the Ethernet for communication, because you are going outside from the realms of your car, really getting data from outside. This is also domain-based architecture. So if I may say, what NXP is doing or any semiconductor supplier is doing for all this sense, think, connect, and act. Sense is your sensing, basically the radar that I talked about, the V2X, equal to anything, communication. Think, the S32 platform and the IMX. S32 and the IMX are ARM-based architecture processors. So in IMX you have something called GPU, graphical processing. We don't talk about in the future parts of a CPU, we talk about GPU. And this GPU is taken from gaming consoles. So you might be shocked to say that what gaming has to do with autonomous driving. Because graphical processing unit really, is quite, is at very high speed. And you can pack millions of processing functions at ease. Correct? You have ultra wideband, infotainment, and vehicle network. And in the act phase, you have electrification. So how does NXP enable zonal architecture in the efficient edge nodes? As you see here, I told you CAN to Ethernet. These are the bridges inside the car. Security and safety, gateways, zonal domain controllers, connecting sensors. So what we do is, on the communication technologies, we have chips developed for communication, CAN, LIN, FlexRay, the 10 megabit Ethernet, and CAN XL. So we are actually transcending the boundaries of CAN from a typical 1 megabit, 5 megabit per second, all the way to 15 megabit and 20 megabit. So we are almost there at 10 base T1S inflection point in Ethernet. So this is audio video bridge, and these are 100 MB and 1 gig are Ethernet. So our competence and differentiation is on high quality, high volume, because this market is very commoditized, and we do a lot of innovation because we supply in billions. Yeah? We supply in billions of quantities, and we do innovation. I will not go block-wise, but you can see under sense, think, and act, what are the verticals and what are the subfunctions. I'll make sure that this presentation is given to Mr. Murthy so that you can get it. Okay, now the interesting part comes. I have talked a lot on what's happening on the technology, and what NXP is doing, but I've come here to interact with students and to kind of establish industry and University Connect. So NXP is doing a lot for universities and engineering colleges like you. We have long-term innovation and university programs. We also do startup collaborations. We foster startups, and we also conduct something called XTC, Extreme Technology Challenge. I will also leave some of the links to you. You can directly log in yourself, and you'll be amazed to see a few of them. What are the possibilities? How can you connect to companies like us? And how can you participate in hackathons? And how can you actually give out your ideas? Because no idea is stupid. Yeah? Every idea, we hear a lot, and we want creative and bright minds like you to really participate, because we are all biased. Being in the industry for many years, every day we talk about that. So some of the things might seem very trivial when we think, but when you think and tell that, probably this is the area where innovation is. We really want to embrace that and foster that thought process. So there is something called NXP Technology Showroom. So if you log in into showroom.nxp.com, you can also do live on your mobile phones. There are many segments where there are virtual showrooms. You can experience some simulations, you can experience. It's kind of an experience studio, I would say. I would not say much, because it's an experience. I can't share that with you. You have to experience. Okay? But the link is showroom.nxp.com. And there's an invitation to play. And I want to inspire you that I would look forward for nominations from this college this year for a hover game challenge. So NXP conducts hover games. So hover games are drone based. Yeah? So for sustainability, for many problems the planet Earth is reeling through, we are inviting and we conduct these hover games every year. So it also says that, how can you ensure that the crop yield is more, mostly on the food safety and security, or how can you use a drone and help a life. So if you log in into hovergames.com, there's a challenge. You can also see in the past how teams have secured places and what they have developed. So a simple thing, when we talk about innovation, first I want to know, what do you understand by innovation? Is it a complex, or what is innovation? Any ideas?
Creating something which is
Sorry?
creating something which solves problem.
Can you be a bit louder?
Creating something which solves any problem.
Okay. Partly yes. Anyone else?
New ideas.
New ideas. Okay. New ideas for what?
Developing any subject.
Okay.
Making work easy.
Making.
Work easy.
Okay. Making life easy, making work easy. So for me, innovation is very intrinsic. It's an intrinsic faculty in yourself. You can ask yourself, I want to brush my teeth this way. I like it. But that's not existing here. I mean, intrinsic innovation comes from the daily life challenges. So how you want things to improve. If you're walking on the road, what is that you expect? What is that you want your mobile to communicate with you? Even if you're not using it, which is good by the way, but if you're walking on the road, what do you want you to be notified? Yeah, even without opening, right? So probably you can say, but it should know that you're walking. It is actually already. No, I'm just telling you as an example. Yeah? So intrinsic innovation is something which is a daily challenge. It can be experienced by you, by others. Also, you can take something which is badly affecting our planet Earth. Sustainability is the need of the hour. So if you are developing solutions for sustainability, welcome. Yeah. Are there hackathons conducted every year? And then you have very good participation. Okay.
They are also encouraging
So, all said and done, what I want to say is, coding should be part of your journey towards excellence, but it is not the only thing that you need to accomplish. There's a lot more, and I am in the midst of very creative and bright minds, fresh out of their +2 or probably first year is getting over, or you just joined first year. This is second sem. Okay. So you're as fresh as out from +2. So I can take that liberty and tell you this. You are not biased, your minds are not polluted yet. Maybe some are, but they're reversible. Please use your time effectively in the college, because I'm telling you, because I have gone through this, you will never get this time again in life. So make use of your time. I'm not a psychologist here, I'm not giving a pep talk on how to make best use of your time. But all that I want to tell you is, latch on to your core discipline that you have selected, because there's a purpose, respect that, and see that what you can do in that, how can you better. So establish networking, think outside, don't confine yourself to what's happening every day in the class. Talk to people, engage in group discussions, look at what's happening outside, participate in hackathons, right? And nowadays I think digital media is at your disposal, on your palm, the world is on your palm. So you can literally learn something which is also not taught in the college. So a big invite to all of you is, I'm here today to inspire you, to ensure that you hook on to your discipline. I'm not saying that software is bad, yeah, please don't carry that message. Software is required. But I'm asking you to holistically look at product development, not just confining yourself to a piece of code, evolve from that. Raise big, keep your expectations sky high, at least you'll reach a tree. Okay? But don't let your expectations saying that, yeah, it's okay, I'll just pass out, I'll get, the job market is open, somebody will hire me, and life is set. No. I think complacency should not set. And don't get into your comfort zone. That's my message. Yeah? Be hungry, as Steve Jobs said, be hungry, be foolish. With that, I conclude this session. Thank you.